Module 1, Statistical Limitations and Innovation versus Commodity. By participating in this module, you will identify the fundamentals of a statistical reliability test and recognize the limits of statistical analysis and the effects of product types.
What we're going to cover this morning is statistical models for reliability testing. We'll take a look at not a bunch of theory or not a bunch of math, but the fundamentals of statistical and reliability tests, why they work, why they don't work, how they've been used historically in testing, particularly in the transportation supply chain, and how the supply chain and the business reality has affected sample size and the duration of testing. The reality is that a lot of what we do and a lot of what is dictated from OEMs and other companies in terms of sample size and test methods is dictated because of the time constraints of the business, not because it's good science. And that's unfortunate, but then again, it means we get the product to market in 18 months for automobiles, maybe 24 months for some things. I've seen as short as 3 months for new product. That's very short, but that's not driven by doing a classical statistical reliability test. So we'll look at some of the common pitfalls that result from that actually lead to a lot of the need for some accelerated testing. And then we'll examine and solve a couple of data set problems, nothing very complicated, no calculators or things like that. All right, statistical reliability test. We can take a look at the ideal versus a practical test. The reality is an ideal statistical test has three characteristics to it. How many of you remember your high school statistics or college statistics? No one remember? All right, there's three things that must be true for statistics. Number one, you have to have a continuous variable, right? Write that down. Continuous. Second thing is, if it's a continuous variable, it has to be homogeneous, right? Not sure how to spell that on the fly, but homogeneous. Continuous, homogeneous, and then the last one is, how big does the sample size have to be? You guys can answer me. It wasn't a rhetorical question. How big is the sample size for statistics? It has to be large. What's typically considered large in most statistics books? No one here took statistics. All right, it's pretty much between 36 and 42 samples. Let's just do a quick survey around the room. How many of you are testing 36 samples of, say, a full transmission? All right. Okay. Minimum is 36. And you're dealing with a product that is relatively low cost. Of course, when you say 36, are you talking about 36 all tested to the same test? Or are they broken up? Right. So this has to be continuous and homogeneous, so one test gets 36 parts. Probably not. Right, we take those 36 and we break it up.
We have some other samples that are combined in each way.
Right.
Like PTC or normal shot, we're all samples.
Yeah, so you'll see a couple that get 36, but a lot of tests get a lot less. Right? Now let's examine this. First of all, continuous variables. It's fairly easy to show that a lot of stuff in our products are not continuous, especially when we talk about design characteristics. If I look at a insert molded through hole in a metal part, so this is metal here, this is plastic here, and I put a cable through there and a ball on the end. This is not a continuous variable. If you look at the gap of this ball versus the metal, those two dimensions, as you vary those dimensions from 1 to 1 being in the middle to where the ball is slightly smaller to the ball is slightly larger. When the ball is larger, you're in compression stress. Plastic can handle that very well. Stress is fairly low. When you're smaller, you're in bending. It's a little bit higher, but not too bad. When the ball is 1 to 1, it's in shear stress, and it actually does that.